All right. We'll go ahead and get started. How's everybody doing? All right, I'm going to be the annoying person. How's everybody doing? That's right. All right. This is Building Apps with the Kinect for Windows SDK. This is the last session for today, and you all were foolish enough to join me. My name is Dan Fernandez. I am from Redmond. We get to travel out to these events in New Orleans and see this wonderful spherical thing called the sun. And we get off the plane and it burns us. So I am really excited to be down in New Orleans. One thing, just before we get started, just thinking about this app. This is Building Apps with the Kinect for Windows SDK. How many of you have actually built a Kinect for Windows SDK app before? OK, good. And how many of you have not? We'll see how many people. Hey, all right, Boolean. People get true or false. That's great. And the rest of the hands, how many realize they're in the wrong session? Wrong session? OK, that guy? Awesome. That's great. Where were you last night? Oh, that's awesome. OK, let's get started. Really, there's two things you should walk away with. What Kinect enables you as a developer to build? Like, what are the possibilities, the scenarios, and how to build those Kinect apps? So that's what I'm going to talk about, to show you just the possibilities, and then show you how you can actually do them. All my demos will be available as well. This is a jam-packed session full of demos, so I'll be taking questions at the end. Because this is the last session, I'll hang out as long as you all want. So for those of you who want to know kind of what are the key topics we're going to talk about, I'll give you an overview of Kinect, how the SDK works. We'll talk about camera basics, how you can actually retrieve data from Kinect, depth data, that's actually distance data that we can get from the Kinect. And really, we're going from a low-level communication data that we're getting directly from the Kinect via USB to a higher-level abstraction that is available via the software side. And that actually gives us things, not just a bunch of points that represent distance, but intelligent data, meaning I can actually find out where the location of a specific human joint is within a 3D coordinate space. Another common scenario is using OpenCV, which is Open Computer Vision. How many people here have ever heard of OpenCV? A couple hands. So you'll get your quick tutorial on how to use a .NET wrapper for OpenCV. But this allows you to do a number of different scenarios. And a lot of people that are building applications want to be able to have the power of Kinect and the depth data and OpenCV. We'll talk about how to use the new Gestures and Interaction API, face tracking, and Kinect Socket Service, which enables you to have your Kinect data over a network. And we'll also talk about the next version of Kinect. Oh, my God. Oh, I'm not the only one. OK, good. And that'll be like a one-slide summary, so don't get too excited. So what's new with Kinect for 1.6? And this is for the people that have programmed Kinect before. So Kinect 1.6, for those of you who've been using it since 1.0, there's a number of improvements. So the depth data API has been improved. Before, you actually got an array of shorts, and you had to do things like bit shifting and bitwise OR and to get at depth data and the player index. Now there's a nice little API that you can walk up and say, hey, for this point, tell me who the player is and how far away it is from the Kinect. There's a new coordinate mapper class. This allows me to map from skeletal space to color space, and I'll show what that means. And then more sensor data. So the infrared camera, which I'll show, and a number of different camera settings. So if you're building camera applications, you can use that as well. And then 1.7, the recent release, adds Kinect interactions. So this means you can have built-in controls for clicking, grip, scroll, and a number of WPF controls as well. OK, so how do we get started? You want to you see the demo, Dan excites you. You're going to go home, and first thing you need is an actual Kinect sensor. So there's two kinds of Kinect sensors. This one that says the word Kinect here is the Kinect for Windows sensor. And the typical Kinect, if you were a gamer, you'd have an Xbox 360 Kinect sensor. The difference is this one has something called near mode, which allows you to get much more closer to the Kinect and get high fidelity data, starting from 30 centimeters or about 15.75 inches away from the Kinect, as opposed to the other one where you're about double that distance. So one thing to note, the Kinect for Windows sensor can't be used for Xbox games. The Xbox Kinect can't be used for commercial applications and does not have near mode. So just realize that that's the high level on the hardware. So in addition to hardware, there's software. Right? The Kinect for Windows SDK does the color, depth, and skeletal data. And then the Kinect for Windows Developer Toolkit includes a number of tools that we're going to use to build applications. So real quick on the basics, because we've got to get into this code. First thing what you want to do is when you're going to add a reference to the Kinect DLL, and you're going to set up a Kinect. So to do that, there's two controls. There's a Kinect sensor chooser, and that comes in the toolkit. And there's a Kinect changed event, and that allows us to gracefully handle losing sensors. Or if you really want to, you can just hard code and say Kinect.Kinect sensors. So now that we have a Kinect, you need to tell it what you want it to do. And what you're going to do is enable different things. Enable the color stream. That's going to show you a color image. The depth stream. That's going to give you distance data. Skeletal, which will give you 20 joints. Audio. And interaction. And interaction is an interesting one because you don't actually need it if you're using the interaction controls. But if you want to go and manually modify those, you can as well. And finally, you start the Kinect. And what you're going to do is, now that you started those, you set up a frame that's going to fire an event. And the one I use, and typically you will use for your applications, is called all frames ready. Meaning 30 frames per second, we're going to get a color, depth, and skeletal data that are synchronized. And you'll get those back, and then you can party on the data. Now, the interaction controls do this automatically. And if you're doing something like X and A that doesn't have events, you can always just pull and do a for loop or your render loop and just have open next frame. OK, camera basics. So before we get into this, and I don't want to spend too much time on this, but just so you all know what's actually happening across this little USB cable is the color data isn't a video stream. What it is a series of images, 30 frames per second, of still images. And those images are in a specific format called BGR32, which is blue, green, red 32. So if we were to kind of listen or hit a breakpoint on Visual Studio, what we'd see is the very first point, which would be 0, 0, of, say, a 640 by 480. We'd see that there's a couple of bytes. In this image, it's blue, green, red, and they're all 255, which is the maximum. So that byte, that pixel in the top corner, would actually be white, as would the next one next to it, 0, 1, and so on. So this becomes important because if we need to process and handle that image, if you need to go to that level and actually set around pixels, and we'll do that in one of our demos, it's good for you to understand what's actually coming from Kinect and the format that you're going to use. The next thing you'll see is sometimes when you're looking at Kinect demos, you'll see the term called stride. And that can be kind of confusing for developers. But what that's basically saying is, hey, I need to know how many bytes this image is. So let's say we had the 80 by 60. We know it's 80 bytes wide. And then for every single byte, I need to have a blue, a green, and a red. And it's also going to have an empty. So it's 80 times 4, which is like 6,000, right? OK, good. No? 320? OK, good, good. So that gives you the basic data. That's the stride that when you're using WPF libraries, if you see the word stride, it just means how many bytes I need to do. Now, this is as technical as we're going to get, because we're going to get into demos. OK, so my first demo, I have Visual Studio installed here. And I've set up, let's just zoom in, under References, Microsoft.Connect, and I do have the Coding for Fun Kinect WPF, which is a little helper, which I'll show, and the Microsoft Kinect Toolkit. So those are the three things I have. And if we just look at our page, we only have two things here. One, we're using a control called Kinect Sensor Chooser UI. Just scroll up. If we look at our toolbox, that's just going to visually tell the user if their Kinect is connected, and you'll see that in a second. So again, there's two rows. That's the first one. And then just underneath it is an image. Can you all read this in the back, by the way? Yeah. All right. Thank you. 640 by 480. OK, so that's our UI. Let's switch into our code view. Now, you're going to see me do a lot of this bitmap handling, and there's a number of things that we can do to simplify. I want you to just see it first, and then we're going to make your life easier so that when you see this code, you're not super scared. OK, so the first thing we're going to do is how we handle the Kinect. Let's get that reference to a Kinect. We're going to use a Kinect sensor chooser. Now, within this main window, we have to define 4 things for the image. The image size, how many pixels, which is that stride, a byte container, which will actually contain all the blue, green, red, blue, green, red, blue, green, red, and then the writable bitmap. And that's what a WPF image needs. So those 4 things for handling an image. Now, when this launches, we call this sensor Kinect changed. And this gives us a nice and simple way to actually be able to handle multiple Kinects, or if somebody accidentally unplugs a Kinect. Now, if I really wanted to, I could just hard code this and do like, let's just do Kinect sensor dot Kinect sensors 0 and get a reference to the first Kinect plugged in. But just as a general, in case there's multiple Kinects or you want to be able to handle those, you probably don't want to handle it that way. The recommended way is to be able to use the Kinect changed. OK. And that sensor chooser UI, that thing on the XAML page, needs to get plugged into a chooser. And then we start the Kinect. So what will happen is the system registers. It fires an event called Kinect change. Hey, I have a new Kinect. The first thing I'm going to do is just make sure to clean up, stop the Kinect, unsubscribe from all frame ready. And when you have a new Kinect, we're going to set up our all frames ready. That'll tell us, hey, Kinect, when you have data, fire this event. And then we need to turn on features. And the first feature we're going to do is called color stream. We're going to enable it. And you can choose the resolution. And I'll choose 640 by 480. And now, again, now that we actually know the dimensions of the image, we can set those to a new rectangle that starts at 0, 0, and goes to the width and height of 640 by 480. The color pixels, we know how many pixels are going to be returned by using this property. And the stride, which is the width times frames, bytes per pixel, which for our image, BGR32 is always 4 because it's BGR empty. So it's 4. But you should, rather than hard coding the number 4, you can always look at this value. And then we create a writable bitmap. And you can set a specific format for that. And just realize we're setting the width, the height, DPI, and the format. And again, we're going to go relatively quickly here because you don't necessarily need to do all this manually. OK, now we've set up the image. Make sure to set the image source. This will fire 30 frames per second and will give us that color data. So anytime we get data from all frames ready, we'll see an E dot, and you can open a color frame, a depth frame, or a skeletal frame. The first thing we need to do is we could be behind, meaning this could be null, and it could be because we're not catching up. And the reason you do this is because you don't want your application, it's showing an image, but that image was from 5 seconds ago, right? You could have those timer issues. So you want to make sure that you're getting fresh data. Now, we also want to make sure we're using to dispose of this as quickly as possible. And we copy the data into that byte array, and then we use write pixels. Another classic thing to do is just when your app is closing, just stop the Kinect. And let's just run this. And OK, so there we see our color image, right? So we built a color image. That's OK, that's pretty boring. But you at least understand some of the things. Now, because there's a lot of code here, we built a helper to be able to make the pain of writing this stuff go away. So I'm just going to switch to that real quick and just reduce that. We still need a color bitmap. And luckily, all these. Now let's fix some code. Let's delete all this stuff. And yeah. Our little helper, what it's going to do, and I'll just use the full namespace here, coding for fun, WPF, writable bitmap helper, dot create writable bitmap. And so long as you pass in the color stream, hey, I can build you an image. You don't have to tell me the dimensions. You don't have to hard code all that stuff. So now we have that, and now we can also just call this as well. Coding for fun.connect, WPF, writable bitmap helper, write pixels for color image frame. So we need two things, the actual color image frame, which in our demo is that, color frame, and then the bitmap. And I think we called it color bitmap. OK, so now our code is a lot probably easier to handle. We do this connect change. We fire this event. And I think I can do that. We'll run. So while this is running, hey, there we have our image. So we've done stuff. Did you see that little thing that popped up? We can also, that was the little sensor chooser. And what I'm going to do is actually unplug it. So I'm going to unplug the Kinect. You'll see it freeze. Ooh, there we go. And we get this. This is the sensor chooser UI control. All we did was set this up. It lets me know that the sensor is required. I'm going to plug this back in. Oh, you're so sweet. OK, we'll start doing the initialization again. And because we had that connect change, it's going to set up that all frames ready again and start eventually getting to this. Now, it does take some time. My laptop is not the workhorse you imagine it to be. But this will actually fire. So this is probably our most basic demo. And all we've done is show, hey, we can handle the state of Connect. We can have multiple connects and so on. We're going to really just build on this in our next demo. But that just shows you the basics of getting a color camera. And again, it's my most boring demo, I promise. OK. Depth data. So real quick, depth data is just the distance and player index for every pixel. Meaning you can decide any pixel that you see, you can get the distance from the Kinect in millimeters. So if it's 2,000 millimeters, that's 6.56 feet away. And you can find out if that pixel represents a person or not by turning on the skeletal tracking, and just within depth data. So let's jump back to our code and show how that works. So first, I'm just going to run it, and then we can walk through the code so you all can see what we're actually doing. But what we're going to do is actually paint with distance. So what this is based on the distance of the Kinect, I am choosing 3 colors. You can see my hand up here. OK, why is that not showing? Let's close. Awesome. Hey, so I'll blame PowerPoint. OK, so what's showing here is my hand is blue, and that's because I'm a certain distance away. And once I hit a certain distance, the pixels will turn green, and then I can just kind of like dissolve into red. So we're basically looping through everything. We can get distance of every single pixel, and it's just a real simple, is it this far away, color blue, this far away, green, this far away, red. And this is great for, I don't know, you can use it for advertising or something. OK. So let's just show what that code looks like. And give me just 1 second to try and find the best place to start. We're going to start in right here. We enable the depth stream. That's a 640 by 480. And we can also turn on specific features, that depth range of near. And we can enable skeleton stream and actually find out if that pixel represents a person or not. Now, we have a bitmap image and a number of things that you all saw before. But what we want to do is go down to the all frames ready. And this time, we're going to handle the open depth image frame. And I built a little method here, which we'll jump to. And this is going to handle all the coloring of bytes. So the way BGR works is B, that blue index is 0, if you see up here. The next one is green, and the next one is red. So you'll see me laying these bytes out one by one manually. And this, again, we're talking about the low-level stuff. as we talk about the later parts, we'll talk about how you don't even need to worry about this using the Kinect interaction controls. But if you need to do this low-level manipulation, you can actually get an array of depth image pixels and read them out. And now what we can do is loop through all the points and get the depth value, right? And that'll tell me for every single point, so the point at 0, 0 is this far away, what do I want to do? Well, if it's less than, because these are millimeters, that's about 2.95 feet. I want you to color it, and we see the blue, green, red. 255, that's the maximum, and I'm only coloring in blue. So that's where you see, if you're close, you're blue. Same thing if you're within 6.56 feet, then you're talking about green, everything green. And any farther away is red. Now, one last thing we can do here, and I'm just going to uncomment this code. We can actually get the player index. You do need that skeleton stream enabled. And now I'll just build a yellow, which is a combination of these colors. And any players, I'll color them yellow. And we can even do things, for example, like, OK, so find out every player, and then find out the average distance of every point. And we're doing that by just, we have a list of all those points. So if you're a player, add those points to this list. And then we can use link and just do a quick query and say, hey, convert these to double because there is no average extension method on a single type. But get all the data and just give me the average distance. And with that average distance, because we are in America, we do the conversion from millimeters to feet to make it easier for you all to follow. And just going to get this going here. So hopefully this will pick up my skeleton. And now what you're seeing is I know the points that represent this person. And now as I get closer, you see the average distance of the points change. So I can actually see how far this person is, the average distance of all the yellow points away from the Kinect, to be able to do this. Cool? All right. So let's open up PowerPoint, and hopefully this works. And what we're going to do now is we've talked about some of the low-level stuff. And for those of you who really need to do low-level, it's good to have examples. But a lot of applications are actually built on the higher level, which is I don't really want to be able to loop through all these points. What I want to do is have a nice abstraction that gives me, turn that data into information. And that's what our skeletal tracking engine does. So what it does is allows you to track up to 2 skeletons per Kinect. That means I can have the 6, and you can have the hip center joint, for 6 people. But I can track for 2 people, I can track 20 different locations of their joints. And you see the list of joints. Or if you've set the skeleton mode to seated, you can track 10 joints. Now, there are 6-player proposals, and you can do things, for example, like, hey, I don't want you to track that specific skeleton. I want you to do this. Find the person who has their hand above their head, for example, and make that the person to track. Once that person's tracked, though, and you'll see these in demos where somebody's playing a Kinect app, you can walk up directly behind them. You're not going to steal their skeleton, if you will. That person is in control, and the Kinect will keep sending the data for that person unless the app specifically chooses. And you as a developer can control that as well. OK, so let's exit out of that and jump. Give a second. Oh, actually, just real quick, before we jump into the skeletal demo, we have joint tracking and smoothing. So now that we have these 20 joints and we're getting the location of those 20 joints 30 frames per second, we can actually get more data about that joint. We can, for example, see if it's tracked, not tracked, or inferred. Not tracked is maybe it's just too far for the Kinect. Inferred may be, like, say, for example, if it can only see part, if your elbow is being cut off, it may infer the location of that. And you can also do things, for example, like not just on a joint basis, but you can ask the entire skeleton and say, hey, is that person being clipped? So, for example, sometimes people get excited and they get too close to the Kinect. You can, at the very bottom line there, you see where you can say the clipped edges. and you can find out that the top is being clipped, and you can tell the person, hey, move back so that we can see you. Or you can adjust the tilt on the Kinect as well. Now, another thing you can do is actually control how smoothing joint data happens. So, and I'll show that in an example, but that basically removes jitter. And it really depends on the scenario of your application. So if you're doing something like an FPS application where you want to make sure you're tracking great, then it's important for you not to have to really control those transform smooth parameters. You may not even want to use them. If you're using something where it's more like the person's flowing and more of a menu control option, then you probably do want to use transform smooth parameters. Now, another thing is the physical interaction zone. So we have guidelines, human interaction guidelines, that show you some of the best practices that we've learned by building Kinect applications. So it's really important to look at these. And one of the key things is that fatigue kills gestures. So for example, imagine an application where you constantly had to move back and forth to control it. Like you would hate the developer. You would want to find them down and hunt them, right? Don't be that person. So to do that, you can actually just, with one simple method called scale to, and design what your physical interaction zone is. So that way, you don't have to, if your hand is a cursor, you don't have to move your hand all the way out. You can make it something more natural where the person isn't hurting themselves. OK. More demos. So the first demo I'm going to show is actually, I'm going to plug in the lights here, and hopefully this doesn't annoy you all. OK, so we are using the Philips Hue lighting controller. So what this allows you to do is, as a developer, you send a query string to this little controller, and you can control lights, right? So wouldn't it be fun if you could control lights with your body? And you can put these wherever you want to in your house, and the kit comes with 3, and it includes hue and saturation values. And the code, of course, we'll make available, so those of you who want to play at home. And let me just go ahead and run the app so you can see it first. And with any luck, it'll actually work. So what we're doing here is turning on skeletal tracking. And what I'm going to do is I have those 2 little ellipses. Those ellipses are going to map to my hand joints. So where my hand joints are, they'll eventually, see, there we go. And you probably can't see that circle really well. What we're going to do is just color based on that and that. Let's just change some of the light colors there. Ooh. Ah. Yes. OK, I'm excited. I don't know about you all. So, thank you. Thank you. Thanks, Mom. OK. So we're able to use this. We get the position of our hands. And then in just WPF, we're moving something to represent our hands. So some of the challenges is the farther away I get, the more a pain it becomes to actually use this, right? So we're going to show how you can change the physical interaction zone so I'm not building software that sucks. The other thing, you'll notice this is a little jittery, meaning it's showing real time, but it stays with my hand. Like you'll see that it stays with my hand, but the movements, sometimes you'll find like in 30 frames per second, maybe 1 or 2 of them are kind of off. So what we can do is actually use the smooth parameters to fix that as well. So first things first, let's jump into the code. And we'll set this to like 130. OK, so what have we turned on this time? We have our color stream. We have our depth stream. We have all frames ready, which is going to fire. These are the same things we've been doing. We're just turning on features. We're going to turn on depth range is near. And we're going to say that we can enable tracking in near range as well. Now, one of the reasons we would do this here is, for example, if you are using a regular Xbox 360, you'll get an invalid operation exception. And if that happens, then we can try the defaults as well. So when that fires, we are going to get 6 skeletons back every time. So this frame skeleton array length is actually pretty much hard-coded to 6. And that's the number of skeletons we're going to get back. And of course, we enable that here. OK. All frames ready. We have a method called update interface. So now what I want to do is actually, let's show this skeleton data first, actually, before we get there. So same way as we've done before, we open a skeleton frame. That 30 frames per second, we make sure we're not dropping a frame, and we're going to copy this data. So now we have 6 potential skeletons, and what you're going to look for is, because this will fire all the time, even if there's nobody there, you have to make sure to look for the tracking state of tracked. So look for the tracking state of tracked and get the first skeleton back. So now we have the specific skeleton that we want, and this includes a bunch of joints. So if we go to update interface, we see first skeleton, and now we can, if you just look at this example, joint type dot, we see that we can get the position of all these different joints and do different things to them in their position. But what's important, though, is this is in skeleton space, not in the coordinate space of the color camera. So how do we make sure that when the skeleton says it's this distance and this x, y, z, that it actually maps to the color camera? That's where we're using the coordinate mapper class. So the coordinate mapper class has an appropriately named function called map skeleton point to color point, which is you give me a position x, y, z, and I will send you back a color image point, an x, y, that represents where that joint is, or that joint position. So now we know where the left hand and the right hands are. And I'll just quickly show this. It's nothing magical, but we're inside the main window, there's those little ellipses. All I'm doing is, and again, if you're using these, the 2 ellipses are within a canvas, I set the left and top property, and that just basically moves them to that x and y. And the only reason we do this width is so it's not in the corner. We do it kind of in the middle and then in the middle. OK, so let me just run back up here, and we'll show, let's comment this one out, and show smoothing. And you'll be able to see the difference here. So these are transform smooth parameters, and what they allow you to do is give you a nice sort of smooth feeling, and I'll just F5 this and run. And you can, of course, set these and play with them and find out what the right settings are for you, but the experience of how the skeletal joints move over that 30 frames per second will actually change based on the variables that we use here. So I'll just give this a second to load up. Find skeletal tracking. OK, so now let's just see if, OK, everything's still working. And notice now it almost behaves like a yo-yo. Right? Before, it was right on top of my hand. Now it just feels a lot smoother. So the user experience, for me, it just seems like a lot smoother. But sometimes, actually, if you notice, I may feel, for example, it's laggy. So it really depends on the experience that you want to have for your application. But it's just a couple lines of code to be able to control how that joint smoothing works. So one last thing is, how do we make sure that physical interaction zone is a lot better? And in that case, I'm just going to go down here, and I'll just uncomment this, and we'll comment these out. So now instead of moving to the exact position, I'm going to scale the position. And what that means is it's just a little override that we have that allows you to scale based on this, meaning the main window width and height. So that way, it's basically a third. So I need to move almost a third of the actual distance. And we'll click Run. And the same thing to be able to set the distance. Now the ellipses, they won't be following my exact position, meaning they won't be on top of my hand. But you'll see that I no longer have to stretch to be able to use this. And I'll just give this a second to finish loading here. And we'll get skeletal tracking working. OK. So now, for example, for me to reach over, and if I move much further back, before it used to be much more difficult. Now I can kind of get the whole way. And to see this kind of in action will actually make this a lot larger. And now for me to get all the way to the left screen and all the way to the right screen is basically that distance. And I can, of course, play with the distance that I want. But this doesn't seem as bad as before, where even just moving from one part of the image to the other part of the image, I was stretching. Ooh, OK. So let me unplug this in case this is annoying you all. And we'll jump back to our next demo. So now that we have skeletal points, what are the things that we can do? Well, the OpenCV image library includes a number of cool features. This is, for example, like one of them is we can actually apply different effects to an image, or effects to a different part of an image. So I'll just run this first, and then we'll walk through the code. So when I'm using the mgu-cv wrapper library, it does have 2 licenses. One is open source. Another one is a commercial license, which does provide support. So depending on which one you want to use. There are C++ libraries for this as well. So what you see are 2 of the exact same images, just the color image. And what I'm going to do is give me my mouse. And hopefully I have enough distance. I'm going to choose different OpenCV effects to apply. But I'm going to apply them to a specific joint. Now it kind of look like, if you see, my head is blurry. So, or we can dilate it. Yeah. That's awesome. Or erode. Now, I've seen some of you after Bourbon Street, and you look exactly like this. And, of course, edge. So edge detection, of course, is great if you're doing something sort of interesting to actually find edges, and as they kind of come on in. It's almost like as they move around, it finds different edges. Oh, that's so freaky. OK, great. And another fun thing that we did was actually, let me see if this, hopefully this will work. I'm going to try. You're crazy, man. You're crazy.
You're crazy, man. You're crazy.
So just the one little fun part. Of course, if you wanted to make sort of an anonymizer app, you now have the video. You can, of course, anonymize your face. And what we're doing there is, and we don't talk a lot about the audio demos, but we're using N-audio to actually add an effect to our sound. And you can, of course, take the code and have fun with it. So what is our application actually doing? Now, OpenCV has a number of different libraries, and they give you about 100 samples in Visual Studio that you can use. Now, one of the caveats, though, is it's built for Windows Forms. So what that means is we have to do a couple different functions to convert what is a Windows Forms system.drawing.bitmap to a WPF version of a writable bitmap that we're all know and love. OK. So let's jump down. And we'll start at our Kinect change. We have our, this represents a system.drawing bitmap. And we also have an OpenCV image. And we're just going to go ahead and, in our all frames ready, we loop through the skeletons. Because this time now we can actually find out the position of the head. And once we know the position of the head, we're going to add an effect region, which is, and by default, we're sizing it 220. And the reason why, and we'll be able to do something better with face tracking later, but remember, a head joint is only one position. It's only XYZ at one point. In our next demo, I'll show you face tracking, where we can actually get the rectangle of the face. And we can actually improve our demo depending on the data. So for now, we basically have a rectangle hard-coded to 220 pixels wide that represents the head. And for each skeleton that is tracked, so if there are 2 people here, they'd both be anonymous or have that effect applied to their head. So, and like before, we get the color point for them. And these effect regions are basically the 2 areas that we're going to apply effects to. And in the color image frame, we need to get back a bitmap source and apply that effect. So let me full screen this. And I'll just move down so we can see this. So the first thing we need to do is we are using system.drawing's way of handling images, which is different than the image and rectangle and writable bitmaps that we saw before. And this requires us saying bitmap lock bits And now we're pushing in the pixel data, which represents all the color camera, all the data from that color camera that we looked at before, the blue, green, red stuff. That's all there. And now it's moved into this bitmap. And OpenCV needs to assign itself a system.drawing.bitmap, and that's the one that we just did. So now we have basically the color picture. Now, instead of the entire image, we're going to build a new image called OVC temp image. And what we're going to do is assign what's called a region of interest. So not just the whole image, just the location of the head. Use that and apply a specific effect to just that. And this part is probably the easiest, where I'm calling one thing, a smooth blur for that blur effect, a dilate, and I can set parameters there, erode. And for edges, I can control this data as well. So now we have a new image called OVC temp image, which is just these pixels, the 220 wide, that have the effect. The next thing I need to do is actually just combine them. So take that blurry part and smack it into the other one, and there's a nice CV copy method that does that for us. And then this very last part is, again, dealing with system.drawing. How do we get a bitmap source? Well, we have to call this create source from bitmap, which basically starts off, and we do the width and height of everything. And this is, I almost hide this, because it's just the part that, how do I convert a system.drawing bitmap to a WPF bitmap? OK. So, and the nice thing is OpenCV just has a number of different things. So people always ask, so what are the capabilities of Kinect? I know I can get human parts, but what if I wanted to, for example, use my phone and have my phone be a controller or a cursor? Or I want to be able to track cats. Or I want to be able to track whatever. What you're probably going to do is use something like OpenCV and our depth camera to be able to get things, for example, like OpenCV has a way for you to track where motion has changed. And you can use the depth camera to get motion data, and then start abstracting out what data can we actually find and do something with. As one example, it actually has what's called optical character recognition. So I'm wearing my Microsoft shirt here. We could, for example, have an app that finds where the center point is and does a rectangle to search for any text. And it could actually read the labels off people's shirts, as one example. So just a number of things, and really, as you're building apps using OpenCV, gives you a lot of power for the kinds of things you want to do. OK. So gestures and interaction. Two things to know about gesture controls. One, we do provide the way for you to get the interaction stream on a low level. But now I want to do it at a high level, meaning I don't even want to write the all frames ready function. I just want to be able to have something Kinect enabled. And wouldn't it be awesome if I didn't have to write any code to handle images and so on for that? So that's really some of the key things. And really, it handles gestures as well. And by gestures, I mean the ability to have your hand be a cursor, the ability to change hands, the ability to click, the ability to grip onto something, and to be able to scroll. And it includes a number of WPF controls that make this a lot easier. All right, let's jump into demos. Make sure that actually exits. OK. Just move this stuff out of the way. OK. So let's open up our gestures project. OK. So I have a very simple XAML file called onebutton.xaml. And make sure it's set to the startup. Great. And within here, zoom in. Right now, we just have a real small image and a sensor chooser UI. And what we want to do is actually add these new Kinect gestures. So they live within Microsoft.Kinect.Toolkit.Controls. And we can drag and drop them into our designer. And the first thing you need to realize, let me just drag this on here. We're going to put them within a Kinect region. Actually, let's just show what this looks like. So real quick, we had that same sensor chooser UI, and we have a camera. There's no, while that's running, actually, let me show you probably some of the quick code behind. All I'm doing is on the all frames ready is populating that image. There's nothing else going on here. It's basically empty. And the only reason I'm doing the all frames ready is to be able to show that image. So within here, we are going to define what's called a Kinect region. Let me make sure to use the namespace, which we added here. Whenever you drag and drop controls, it'll automatically do this for us, but we'll just do k:, Kinect region. And I'm just going to put this in the second row. And you'll see, just by those little highlights, it's now filling that entire second row. Now, to Kinect enable these controls, I just need to add them. I'll add a Kinect circle button. And we'll say content equals yes. OK, so there's our real basic button. The one thing, if you notice, we did have that sensor chooser. This Kinect region needs to be set up to use one. And in this case, within the Kinect region, we'll go use our property window. And we'll use some real quick data binding for the Kinect sensor. So I'll click the little icon, create data binding. And what we're going to do is data bind to what stuff we have in our page. We have a stack panel, and we have UX sensor chooser. And that has a Kinect property. So all this is doing is just basically adding this code. So now my Kinect region is associated with a Kinect, and I add a circle button. And we'll do a real quick event here. And in here, we'll say, let's call what was called a Kinect circle button. Button equals Kinect circle button sender. And just so we know that we've changed it, we'll just send the foreground equal to a new color, and we'll do a solid color brush red. OK. So I'm going to F5 this. We didn't have any interaction stream methods in all frames ready. Remember, it's just that color image. And it should come up in just a second here. So there's our button. And I'm going to full screen this. And this is really designed to be in a 1920 by 1280. So now what you see is all I did was add XAML. I added a Kinect region, and I put a button on it, and I associated with it. And now I get, and if I switch hands, you'll see it switches hands. And of course, now I lost my hand. Oh, there it is. OK. So I'll just show, this is just a click event, and it happens to be built directly into the control. And notice as I get closer, in typical Kinects, we used to have where you mouse over something and a timer would start. Right? Now you can just use this, and it has a click button. And of course, when I click it, the click event fires. So there isn't really a lot of magic. I didn't have to write code to be able to handle where this cursor is, what the size of the dimensions are, and so on. So really nice features from an interaction perspective to add basic click events. And of course, if we just can add multiple controls in here. And at this point, really, you're not programming Kinect. You're just programming XAML. So if I try and add another button here, it's going to give me a little error, and Visual Studio is ever so nice and says, the property content can only be set once. And you're probably familiar with that if you've done XAML, where this all needs to be within a container control. And we'll just choose a stack panel. And I'm just going to wrap these in here. and say no. And there's our beautiful interface. And if I run this, of course, whatever button I press, and we can, of course, set the maximize value as well once this comes up. The click event we basically get for free. The hand tracking we get for free. And if you do need to tweak them, though, you can sign up for, in the Kinect sensor, the interactions stream ready event. And within there, you can customize both the cursors. These buttons, you can completely customize as well. Let me make sure to maximize this. And we'll get, yeah. So you'll notice it's a little jumpy as well. So we can also set the smoothing parameters, just like we did in the other example, to be able to control that. So we've shown basic click events, but what about grip and scroll? So I'm going to switch to another pre-built app here. And what I'm doing is just starting the main window one. I'm just going here and Startup UI, select main window. OK. And our main window, if we just do a view code, and we have our Kinect sensor change. We turn features on. And you do need to enable things like the color depth and skeleton stream. But I have no other code that handles all frames ready. Everything is just handled for me within these. And the one thing I'm going to do is when you select an item, I'm going to start a new process and just open up Internet Explorer and send in, because what we're going to be doing is looking at a list of TechEd sessions. And I'll show you the data context, but this is just a URL to a specific session. We call demodatasource.getAllData, and let's just follow that real quick. And we're setting the data binding here, and this just basically gets all data. And not find reference, go to definition. And this is just basic data from the RSS that's available on channel 9. We built into a nice class, and now we're going to data bind it and use controls. So at this point, we're in main window, and we're able to get Kinect data, and now we are just a XAML developer. We just need to set properties in XAML to decide what we want this thing to look like. So actually, let me see if I can full screen this. And we'll double click there. OK. So we have a Kinect region. I'll just minimize that so we see. The Kinect region is basically the area we're going to do everything in. And it's exactly the same as that one button, except now we have a different control. And now we're going to be using a Kinect scroll viewer. And that allows us to have a scrollable area. And we can set how we want to be able to scroll that. And if you're familiar with the items control in WPF or XAML, this is just the Kinect-enabled version. And that allows me to set, and I'm just going to minimize these so you can see them all together. You can control all sorts of stuff, the base control that it's using. You can control the items panel, which is the container control. In that case, I want all these little sessions to pop in and be in a stack panel that moves horizontally, right? And I can control that template. Within the container style, meaning the specific item container, this is a Kinect tile button. I can now choose the size of that button, or I completely choose the different layout. In this case, I'm just making them large. I'm making it width and height. And now to actually do the data binding. So we have that session info from TechEd. All we're doing is we set the data context, and then we set two properties, the session image and the name. So what you don't see here, again, is Kinect enable any code specific to controlling Kinect. Just by putting it in the Kinect region, we get all that stuff for us for free. And let's click Run, and hopefully this all works. And what it's doing is, I swear it's not making a call over the network. I actually saved the local file, but it does, unfortunately, load 500 versions of the same image. So now we've enabled this. I see my hand cursor. Now watch as I close my hand. It becomes that grip icon. And I can, for example, close, and you actually see sort of inertia happen here. And close, and whenever I want to stop, I can close my hand again. So I've just added grip and scroll. I didn't write any code to do that. All we're doing is really styling how we want these controls to work. And let's see, building apps with the Kinect for Windows SDK, best session at TechEd, click. Oh, the internet doesn't work. Oh, that's great. OK. Oh, that's hilarious. I forgot I'm on a local network to make sure that one works. But I swear it does actually open a browser, and it does go to the correct address. So we've kind of built up these controls. We showed how to use basic controls. We showed how to use the scroll viewer control. What if I want to build something a little more robust? One of the great things is, and I'll just show this real quick, the Developer Toolkit browser includes a number of different controls that you can use and samples. So the control toolkits are all within here. The human interface guidelines are within here as well. And the example I'm going to use is and I think I have it downloaded already. Or actually, I know I have it downloaded already. Let me just open it up here. It's called Interaction Gallery. And this is sort of the full bore. What could you imagine doing with gestures? And I'll go ahead and just start running this. And this has a number of different screens. You can imagine this, say, like out in a lobby, and it starts picking me up. And once it picks me up with that shadow there, it tells you to get started, lift your hand. So I lift my hand, and I see the cursor. It shows me the click event. Now I have a click event. Now I have these menus, and these are just buttons. The same, instead of circle buttons, they're tile buttons. And we can have, for example, a video player, or we can, let's just select an article. And now, before we were going through a list horizontally, now we can actually just read down this way. Using that same grip command, I can now read text. And, of course, click and open some beautiful images. So this is a really nice example. If you're looking for something, we kind of started small, and you want to see something of a real application that you can take and reuse code. It's a great demo sample. OK, let me close this. And we have two quick demos that I want to jump to. And let me just jump into face tracking. So face tracking is ever so fun. Instead of just knowing the position of a head, now we can actually track up to 120 points on a head and know the orientation of that head. So let me just show you the demo, and then we'll walk through the code. I'll give this a second. And the face tracking, again, the library for interactions and gestures and face tracking is not in the SDK. It's in the toolkit. So you do need to have that toolkit that I showed in that toolkit browser to be able to use these. So what I'm going to do is actually use the position of the head. And now you can see, oh, look, what's he thinking? So much fun. OK, so I tried to do some basic gestures. So now I can track. Imagine building applications that respond to human emotion, right? Like, imagine this is a display, and there's a I'm thinking Arby's logo that's going there. And if I try and shake my head, no, not in here, So what we're going to do is that's tracking the position of the head. So you have roll, pitch, and yaw, and up to a specific level. Now what we want to do is actually show, and I'll just show these real quickly so you can see them all. These are called animation units. So how can we react to human emotion? We can track the position. Is your lip raised? Are you giving a happy smile? Do you have a Joker smile? Is your brows up? And a number of these different states, and we can change our application and actually react to human emotion in our applications. So let's show how to do that. So we have our all frames ready, which you all are familiar with. And the face tracker is what we're going to use. And it has a track method. And what I need to do is send it all the data the other things provide, that color, depth, and skeleton, send it all to it. And it'll tell me if it's successful. And if it's successful, I get a ton of data. So, so what you'll see is I pass in the format so it knows the size of the color camera, the size of the depth stream, the first skeleton that I want to track for the face, and all the data. And if tracking is successful, well, I turn on that thought bubble, and I'm going to go to Analyze Face. And what I'm doing is basically using that same move to camera position, doing a little offset so that thought bubble follows me. And for yes, I basically look at the rotation up to, if it's anything larger than 10 degrees, start a little timer that says, hey, they started a yes. And if I ever go back down within 3 seconds, I know it's a yes. So it's a very rudimentary, basic way to track yes. And same thing with no. And my nose are hard-coded, so you have to look left first. So if you're one of those people, these weird people that look right first, when you look at no, this code won't work. Yeah, everybody's with me. Everybody look left. Anybody not look left when they say no? OK. That guy? All right, thank you. All right, so let's actually play with some of the animation units. So let's call this animation units equals. And that face track frame, 30 frames per second, I can get a ton of data, right? So the triangles, the animation units, animation unit coefficients is what I want. And now I'll do a quick if, animation units, and this has a nice little enum. So the jaw lower. So if somebody lowers their jaw, what action do we want to take? And what I'll say is if it's greater than, let's try 0.7, we're going to update our thought bubble, which is a set thought bubble. And we're just going to update the image. And in this case, we have a couple different images here. And we'll call it openmouth.png. Same thing, we're going to just do animation unit. And this time, let's check if somebody's raising their eyebrows. And we'll set the thought bubble. And this one's called eyebrow. Now, there's obviously something wrong with my logic in that somebody can be both raising their eyebrow and opening their mouth at the same time. But you get the general idea of it's incredibly easy as a developer to find out what a human face is doing. I know the position. I know the coordinates of over 100 different points. And let's see. Ooh, one last thing is I'll actually enable this so we can actually read that data as well. So animation units, animation unit. I just want to be able to display that value. Was that? That was brow raiser, and now open mouth. Animation units, which I think is called jaw lower. Great. And this will just give me a way to actually be able to see the value on that app. And I'll give this a second to load up. Now, when you're playing with these applications, I'm obviously hard coding them. You're probably going to want to do some more things like, for example, record all the different values, find out what a minimum, maximum is for a specific person, and find out what a good range is. So what you see is there on that current is the values. So if I try and do like a, hey, there's my happy face, or hey, crazy eyebrow guy, hey. All right, so this is, yes, this was a fun demo, yes, yes. So there's so much power in the face tracking SDK, and a lot of people are building on top of this, including things, for example, like eye tracking. So there's a lot of cool stuff that I think will be coming down the road, and this is just really the beginning of handling this stuff. So last demo I want to show here is using the Kinect service. And the idea here is, let's say I have multiple Kinects within an installation, and I want to display data from all of them. Or I have multiple PCs. I need to have some way to get at that data. Or I'm using a Windows Phone. I want to display Kinect data, that face data, directly on my phone, or in a Windows Store application. So what I'm going to do is use a project that's available called connectservice.codeplex.com. And within here, you'll see samples. It includes clients. Those are what's going to call the Kinect over the service, and a host. And what I'm going to do is just spin up a quick host. And you can either do a console or a Windows service. And I'm just going to start this up. And while that's starting up, this is going to now expose that Kinect color, audio, depth, and skeletal data over a network. And I can subscribe to it somewhere else. I can subscribe to it, maybe dump the data into Azure, or whatever example you want to be able to do. Let's start up the processing viewer. And we're actually going to use a JavaScript demo for a Windows Store app, just to show that it isn't just a C# to C# thing. We're now in a Windows Store application. And what I'm going to do is, first off, there's a library, a WinMD library that I'm going to reference. And that's the Kinect service. And now within here, if I just scroll all the way to the top, what I want to be able to do is just have some variables for the position, the x and y of the left hand and the x and y of the right hand. And I create a skeleton client. And the IP address, by default, it's going to be 127.0.0.1, which is my local machine. And like before, we're going to set up an on-skeleton frame ready, and that's going to fire whenever there's skeleton data. Except this time, it's not firing locally. It's sending me data over the network. And I do a quick connect to a specific port. 4530 is color, depth is 3.1, and skeleton is 3.2. And it's going to fire that. And what's going to happen is when we get data, it goes to the skeleton frame handler. And let's just go down to there. And this code should be somewhat familiar. This will fire. We loop through the 6 skeletons that we receive. If one of them is tracked, then we set this skeleton and actually get the position, the x and y position of the hands. And I'll just go ahead and run this. So really, it's the same looking API, except now we've made Kinect data over the network. So let's see if we can. And what this is using the processing visual library. And I have a cursor there. That's kind of annoying me. So this is all JavaScript here. And it's a great library for doing this, and great for kids. And it does a number of things where there's emitters basically with my hand and little particles that fall off based on the direction of my hands. So, but all this is happening over the network. It's not actually connecting to my app. OK. So we've talked a lot about apps. The last thing that I'm sure you're all waiting for is talking about the new Kinect for Windows SDK sensor. So we announced, for those of you who saw the Xbox One announced, there is more announcements coming for E3, which I believe is next week. And the key things that we've made announcements for is that the Kinect for Windows sensor, the Kinect for Windows sensor, so there's the Kinect for Xbox. We are going to have a new Kinect for Windows sensor that's based on that Xbox One sensor. We're also going to update our SDK based on that as well. So what that means is we get a number of the features that you've probably seen before if you've seen some of the videos on the new Kinect for Windows sensor. That means new active infrared. So you can play and get data from the IR camera in almost complete darkness. An HD camera. So we've been using a camera that is a 640 by 480 camera. The last time you probably used one of those was in like 1999. Now we're getting a 1080p video directly from Kinect. We get a much wider field of view. So we're able to actually have, for example, and this comes into handy with improved skeletal tracking, where instead of 2 positions of skeleton joints, we can actually get 6 people at the same time and get all of their skeleton joints. Expressions and hand gestures. So you've seen some of the things that we've done with gestures and interactions. We're going to improve those, as well as human expressions using your face. And improved voice recognition as well. And this will be coming next year. So it's all very, very exciting stuff. Oh. Okay. So that's everything. Thank you all for staying. I know this is the last session. I'm going to be here as long as you want for questions. And thank you all for coming.